Hey guys, today we're going to be reviewing what happened during the live session. Um, I'm just going to give you a few reminders. The first reminder is that live lessons are requirements, so make sure that you are there every Monday, 11 a.m. If you're fifth, third, fifth, and seventh, or seventh, if you're sixth period, I'll see you at 2 p.m. Next reminder is that algebra support is going to be available through Remind at 2 p.m. If you need to do a face conference, just send me an email. Mandatory tutoring will start on Tuesday. Make sure you check your emails for in case you are mandated to come tutoring. Last announcement is that if you didn't complete any missing work before 4/20th, make sure you email me and Jason with the date and the name of the assignment so we can grade it. If you do not email, that assignment from other weeks will not be graded. Today is Monday. We have a live lesson and a small practice, so make sure that you watch the video first. If you did not attend, of course, you watch the video. The lesson. Our essential question for this unit is how do the groups that we create impact an outcome? Not only in math, but also in life. Our friendships, how the groups of friends that we have impact our actions. And we're going to be linking that math idea, that question with math and also the real life. Our first problem is asking to find the total area of a house, of a window. And our learning target for today is to multiply polynomials and recognize the solution also as a polynomial. So let's start with the measurements of the window. Our window measures 3x plus 3 on the sides. So that means this here is x plus 3. Sorry. This here is x plus 3. And this here is also x plus 3. I can definitely write x plus 3 in each side, but since I'm looking for the area, you've done this before. The formula for the area is a equals length times width. So I just need two sides for now. My length is 3x plus 3, so x plus 3. And my width is x plus 3. I would like to link this problem to the idea of recognizing a expression and with an exponent, So this expression here is equivalent to this expression. You remember when we work with exponents and we introduce x squared, and at the top I have x squared is the same as x times x. This is a very similar example, just now that we don't have only x, but we have x plus 3 squared. And we have to multiply that whole thing 2 times. Now we're going to use a method, the box method, which I like the most. The box method looks like this. You draw a box and then you split the box based on the number of terms of each side. So the length has 2 terms, it's a binomial. So I split the box right here into. Okay, and now my width has 2 terms, and that's my width. That's where I place them. Now I go again and go back to the idea of the law of exponents that we learned a few weeks ago. We say that x times x is equal to x squared. Remember that there an exponent 1 here, which when you multiply the x's, you add the exponents. Moving to the right side, x times 3 is positive 3x. And moving down here on the left is x times 3 again is positive 3x. And the last square here is 3 times 3, which is positive 9. What happens here is we need to find like terms. So last time we looked at a similar problem, we said that most of the time this 2 right here will be like terms. And our final answer will be x squared. I don't add x squared with anything else because no other term has an x squared. Then I add 3 plus 3 is positive 6x. And then plus 9. I want to make sure that you guys see a pattern within this expression and the final answer. If you notice, the middle term is 6, and if you add the numbers right here, these numbers, you get 6. But when you multiply the same numbers, you get 9, and that's the last answer. So add the numbers is the middle, multiply the numbers is the last term. And x squared will be there all the time because we do have 2 x's that will be multiplied. So this is our area. Area equals x squared plus 6x plus 9. Our next example is called difference of squares. And we're going to see why. Find the area of a rectangular basketball field whose length is 2x plus 1 and width is 2x minus 1. So again, my length is here, 2x plus 1. And my width is 2x minus 1. Again, my area formula is A equals length times width. And I'm going to go ahead and use parentheses. So 2x plus 1 times 2x minus 1. Good. And I, again, like the box method. So I'm going to draw my box, split it in 2, 4. And then I'm going to place the first polynomial, my length, on the left-hand side. So 2x on the first box, positive 1 on the second box, or outside of it. And then I go ahead and do this one right here. So 2x minus 1. I'm going to go ahead and, can I have a different color? Gray. I'm going to go ahead and multiply 2 times 2 is 4. X times x is x squared. Boom. Now 2x times negative 1 is negative 2x. 2x times positive 1 is positive 2x. And 1 times negative 1 is negative 1. Now that we have our small areas, now we're going to add them up to find the total area. So what we do is 4x squared does not have any other like terms. So this is 4x squared. These two are like terms. So positive 2 minus 2, they will cancel out. And you end up with negative 1. And this type of example is called difference of squares, as we multiply 2 binomials and we end up with another binomial. And there's like a little I don't know, I don't want to call it a shortcut, but if you notice, 4x squared comes from 2x times 2x, and negative 1 comes from positive 1 and negative 1, and I'm done. Whatever is in the middle, it will cancel out. So this is a special, I'm going to put a heart next to it. It's a special example, a special case. So now that we have seen 2 examples, we would like to make a small test on predicting, right? And because this example looks like our first example, I can expand this to be this, right? And if you go back to the example, I can definitely go ahead and do the box method, but I know that my first term will be x squared because I have two x's. My second term will be the addition of, let me do blue, the addition of 5 and 5, which will be 10x because it's in the middle. It will be 10x. And my last one I'm going to do in green is the multiplication, which is 25. Again, you don't have to go with this thinking. It's just a different way of looking at it because there is a pattern. So if I give you x plus 6 times x plus 6, you will see the same pattern. The second one is a difference of square example where you, I don't want to call it a shortcut, but the noticing or the way we visualize this problem is that, well, I'm going to multiply the first two. So it will be 3 times 3 is 9. X times x is x squared. And because I already know or seen that the two middles cancel out, I'm just going to multiply the last two and it becomes -1. And that will be my answer. And if you want to go ahead and check with and do the box method, and I want to check, just make sure that you don't say, oh, Casey told me to do it like this. I just want you to check it. So let's check. I have my first term. All right. My first term here is 3x, and my second term is +1. On the other side, I have 3x and -1. So if I do 3 times 3 is 9x squared. If I do 3x times -1 is -3x. If I do 3x plus 1, it will be positive 3x. And if I do +1 times -1, it will be -1. If you notice, these two are like terms, but they also cancel because they're opposite. And I end up with 9x squared minus 1. And that was a check.